The legendary stealth bomber has the United States F-117 Nighthawk apparently also has the ability to duel with other aircraft in the air or air-to-air dogfight. This was revealed by a veteran of Michigan Air National Guard, namely Major Robert Robson. Donaldson appeared on the internet radio show Fighter Pilot podcast owned by former Top Gun instructor Vincent Jell-O, Aiello, on February 13, 2020. As a bomber, of course many are asking why this aircraft uses the letter F, which means fighter, while an official U.S. Air Force, American bomber aircraft uses the code B. Well, Donaldson also answered the curiosity of the connoisseurs of the military world. Its main role is attack, but the aircraft can carry all the ammunition and inventory when it starts to be used. With the exception of Sparrow missiles guided by radar, so we can carry air-to-air missiles, we can carry air-to-ground missiles and everything, he said. So all missiles for air and land targets can be carried by this aircraft. Then what are the air-to-air missiles for? It turned out that the F-117 was made with a secondary aim of ambushing and chasing Soviet Union AWACS aircraft. The primary objective is clearly as a target bomber on land. Our secondary role was to shoot down Soviet AWACS aircraft. So yes, we are not visible on their radar and we don't want them to be able to control their airspace, so, however, we can intercept Soviet AWACS planes on the side of our plane without them knowing, Donaldson said. The F-117 Nighthawk is an American single-engine, double-capacity stealth attack aircraft developed by the secret Lockheed Skunk Works division and operated by the United States Air Force, USAF. The F-117 is based on HAVBlue technology demonstrators. The Nighthawk was the first operational aircraft designed with stealth technology. The inaugural flight took place in 1981 in Groom Lake, Nevada, and the aircraft achieved initial operational capability status in 1983. Nighthawk was shrouded in secrecy until disclosed to the public in 1988. Of the 64 F-117s built, 59 were production versions, with 5 others be a prototype. The F-117 was widely publicized in 1991. Although it is generally referred to as the stealth fighter, it was truly a ground attack aircraft. The U.S. Air Force retired F-117 in April 2008, mainly because it fielded an F-22 Raptor. Despite this type of retirement, a portion of the fleet has been kept in airworthy condition, and the Nighthawks have been observed flying in 2020. When the Air Force first approached Lockheed with a stealth concept, Skunk Works director Kelly Johnson proposed a rounded design. He believed smoothly blended shapes offered the best combination of speed and stealth. However, his assistant, Ben Rich, showed that faceted angle surfaces would provide significant reduction in radar signature, and the necessary aerodynamic control could be provided with computer units. A May 1975 Skunk Works report, Progress Report Number 2, High Stealth Conceptual Studies, showed the rounded concept that was rejected in favor of the flat-sided approach. The resulting unusual design surprised and puzzled experienced pilots. A Royal Air Force pilot, who flew it as an exchange officer while it was still a secret project, stated that when he first saw a photograph of the F-117, he promptly giggled and thought, "Ooh, this clearly can't fly." Early stealth aircraft were designed with a focus on minimal radar cross-section (RCS) rather than aerodynamic performance. Highly stealthy aircraft like the F-117 Nighthawk are aerodynamically unstable in all 3 aircraft principal axes and require constant flight corrections from a fly-by-wire (FBW) flight system to maintain controlled flight. It is shaped to deflect radar signals and is approximately the size of an F-15 Eagle. The single-seat Nighthawk is powered by 2 non-afterburning General Electric F404 turbofan engines. It is air refuelable and features a V-tail. The maximum speed is 623 miles per hour, 1,003 kilometers per hour. At high altitude, the max rate of climb is 2,820 feet, 860 meters per minute. And service ceiling is 43,000 to 45,000 feet, 13,000 to 14,000 meters. The cockpit was quite spacious with ergonomic displays and controls, but the field of view was somewhat obstructed with a large blind spot to the rear. It has quadruple redundant fly-by-wire flight controls. To lower development costs, the avionics, fly-by-wire systems, and other parts were derived from the General Dynamics F-16 Fighting Falcon, McDonnell Douglas F-A-18 Hornet, and McDonnell Douglas F-117 Strike Eagle. The parts were originally described as spares on budgets for these aircraft to keep the F-117 project secret. The aircraft is equipped with sophisticated navigation and attack systems integrated into a digital avionics suite. It navigates primarily by GPS and high-accuracy inertial navigation. Missions are coordinated by an automated planning system that can automatically perform all aspects of an attack mission, including weapons release. Targets are acquired by a thermal imaging infrared system, slave to a laser rangefinder, laser designator that finds the range and designates targets for laser-guided bombs. The F-117A's split internal bay can carry 5,000 pounds, 2,300 kilograms of ordnance. Typical weapons are a pair of GBU-10, GBU-12, or GBEU-27 laser-guided bombs, two Blue 109 penetration bombs, are two Joint Direct Attack Munitions JDAMs, a GPS-INS guided standoff bomb. The F-117 has a radar cross-section of about 0.001 square meters, 0.0108 square feet, 42. Among the penalties for stealth are lower engine thrust due to losses in the inlet and outlet, a very low wing aspect ratio, and a high sweep angle, 50 degrees, needed to deflect incoming radar waves to the sides. With these design considerations and no afterburner, the F-117 is limited to subsonic speeds. The F-117A carries no radar, which lowers emissions and cross-section, and whether it carries any radar detection equipment is classified. Its faceted shape made from two-dimensional flat surfaces resulted from the limitations of the 1970s-era computer technology used to calculate its radar cross-section. Later supercomputers made it possible for subsequent aircraft like the B0mber to use curved surfaces while maintaining stealth, through the use of far more computational resources to perform the additional calculations. An exhaust plume contributes a significant infrared signature. The F-117 reduces IR signature with a non-circular tailpipe, a slit shape to minimize the exhaust cross-section and maximize the mixing of hot exhaust with cool ambient air. The F-117 lacks afterburners because the hot exhaust would increase the infrared signature, and breaking the sound barrier would produce an obvious sonic boom, as well as surface heating of the aircraft skin, which also increases the infrared footprint. As a result, its performance in air combat maneuvering required in a dogfight would never match that of a dedicated fighter aircraft. This was unimportant in the case of this aircraft since it was designed to be a bomber. Passive multi-static radar. The static radar and especially multi-static radar systems detect some stealth aircraft better than conventional monostatic radars. Since first-generation stealth technology, such as the F-117, reflects energy away from the transmitter's line of sight, effectively increasing the radar cross-section (RCS) in other directions, which the passive radars monitor.